Hello and welcome to this presentation that describes the Mobius Institute Category 1 Vibration Training course. My name is Jason Tranter, the founder of Mobius Institute, and I'd just like to take you through what the course is about, who it's intended for, and then actually go through the topics in just a little bit of detail each one, so that not only do you know what we cover on the course, but you will see some of the animations and the simulations that we use during the course. So if you're really wondering, should I take the Mobius Institute course or maybe another course, then I hope this will settle that question once and for all. And if you're wondering whether the Category 1 course is really suited for you and maybe the Category 2 course would be better, well then hopefully this will answer that question too. So, who is the Category 1 course intended for? What is the course? It is excellent for new vibration analysts. So if you are right now measuring the vibration or about to get started in vibration analysis and maybe just getting started into spectrum analysis, then this is ideal for you. This is definitely the place to start. We really take a lot of time to carefully teach the fundamentals of vibration. We talk about data collection and just how important it is to repeatedly take the measurements properly. We introduce the idea of the analysis process. We give you an introduction to spectrum analysis and diagnosing faults and correcting some of the faults. And we try to paint the bigger picture rather than just focusing on you as a person collecting measurements and maybe doing a little bit of analysis. We just want to take a little bit of time to say, well, vibration is one part of the condition monitoring process, and that the condition monitoring process is just one part of the bigger maintenance picture. So just explaining what predictive maintenance is about, how it compares to preventive or calendar-based maintenance, and the benefits of precision-based maintenance, reliability-centered maintenance. We don't spend a lot of time on those things, but it's just important for you to understand just why you're doing what you are doing. What are the goals of the vibration of the Mobius Institute course? Our number one goal is to make you a better vibration analyst, to prepare you for the work that you have to do so that you understand what you're doing and so that you can do it well. There's no doubt that a lot of people take the course because they know there's an exam which you could take with us or with another organisation. You can do it as an ISO standard course and exam or ASNT recommended practice. The course is obviously great preparation for the exam, but we're not just going to sit in class and just prime you for the exam. We want to make sure you come out a better vibration analyst than when you started the course. Our real goal is to help you understand. We're not just going to force feed you with fact after fact after fact, which is the traditional way to teach these courses. Just hit you with a number of facts. We explain everything. We use our simulations and animations that you'll see soon to explain why you have to do things, why the vibration changes the way it is, the way it does, what happens inside the machine and how the vibration measurements work and so on. The other thing is that whereas the ISO standards speak about certain topics that you must have been trained on in order to be a Category 1 vibration analyst, we recognise that it might be another year or 18 months or longer until you take the next course, and that's a long time. You need preparation between now and then to perform the sorts of functions that you will in that time. So our courses all go beyond the standard. We cover the standard, of course, we cover the topics we have to cover, but we do go further so that as you start to do the functions that are sort of expected of, in this case, a Category 2 vibration analyst, you'll actually understand what you're doing rather than doing it without the proper training. What are the features of our courses? Well, we have lots of animations and simulations that you will see soon. We asked you some questions during the course just to make sure you understand what it is you've been taught, rather than facing issues out in the field or on the exam paper that you just don't understand. As I mentioned, we do train sort of above the standard, and for what it's worth, we offer these courses all over the world. We teach the course in many, many languages. We make the course available online as well as live courses. We really want to help you no matter what language you speak and where you are in the world, which is really good for sort of corporate standardization as well, so that all of your sister plants, everyone can be trained the same way. What are the benefits of our training? The animations and simulations make it easier to understand what you're being taught. You will have what we call the aha moment, over and over. You will be being taught things that you may think are going to be complicated. You'll see the animation or the simulation and think, now I get it, now I understand, that wasn't so hard. All of that means that you actually learn faster and you retain things because you've got a great visual image. You understand what's going on. It's not just dry, boring facts that you have to remember. We do try to turn you into a good vibration analyst that understands the other condition monitoring technologies and the bigger picture. And a very big difference between our training and the other training is that we prepare you before the course and we assist you after the course. Learning about vibration shouldn't be something that you just do in 3 days and that's it, that's everything. There is a lot to learn, and we're not all super geniuses that can absorb the information quickly, even with the assistance of the animations and simulations. So we offer you the option, and a free option, of registering as early as you like for the course and being given access to our learning zone. In the learning zone, you can go through self-paced, fully narrated training that prepares you for the course, so that when you attend the course and you start to hear about the various terms, frequency, amplitude, spectrum, vibration, all these sorts of things, it won't be the first time you've heard them. You will have gone through some online training, prepared yourself, and it'll make so much more sense during the course. But just in case you can't remember absolutely everything, after the course, for the next 6 months, you can continue to access the learning zone. And then if you're willing to spend a little bit of money with us, you can continue that access for as long as you like, and you can take advantage of all the other products and services that we offer to assist you as a vibration analyst. So our training doesn't just go for 3 days and then we leave you alone. We realize that learning needs to be an ongoing thing. You're going to need help all the way through that process, and we're there with all sorts of services and products and resources on our website to help you with that. So who should attend? Basically, if you have less than about 12 months experience in vibration, then this course is ideal. It's going to set you up with the fundamentals, and it's going to teach you everything you need to know before you take the next step into full-blown vibration analysis. But I should say that we have a lot of people, maybe half the people who attend our Category 1 course aren't actually vibration analysts, which means you can't be certified as a vibration analyst unless you have the experience required. But we have maintenance planners, maintenance managers, production people, reliability engineers, operators, and many other people who will just simply benefit from understanding the maintenance practices, the condition monitoring technologies, and by having a better understanding of vibration. If these guys all understand what you are doing as a vibration analyst, the work in the plant is so much easier. Everyone is more supportive. It is amazing, the difference between the site where there's just one or two guys doing vibration analysis and no one really understands what they're doing, no one else is trained at all, it's just the vibration guys, and it can sometimes seem like it's the vibration guys against the world. On the other hand, in the plants where other people have also taken some of this training and they've perhaps used awareness training to teach millwrights and mechanics and technicians and fitters and whoever in the plant, if everyone has an understanding of what this is all about, it is amazing the difference it makes. It is just amazing, but that maybe is really for another topic. Anyway, let's have a quick look at the topics we cover, and then we will go through them in a bit more detail. Maintenance practices explain breakdown, precision maintenance, preventive maintenance and predictive maintenance. We go through a quick introduction to each of the condition monitoring technologies. We spend a lot of time on the vibration fundamentals. We make absolutely sure that when you look at any vibration readings or look at the spectrum, you have a really solid understanding of what it means. You're not going to walk out of a Category 1 course a real vibration expert able to diagnose lots of faults and all of that, but you will really have a solid understanding of what it's all about. You will believe without any doubt that if the machine condition changes, the vibration will change, and you will have started down that journey to be able to understand the spectral measurements. We give you a quick introduction to signal processing, and all that means is, what are those settings in the analyzer and how important are they? It's amazing how many people do not have their data collector or vibration analyzer set up properly when they take the measurements. So part of this is to explain, don't change the settings unless you understand what they mean, but also to really think carefully about how it's set up to make sure it's done properly. We spend a lot of time on data acquisition to make sure that the measurements are being taken carefully and correctly, and we'll talk more about that in a minute. But there's a lot of time on vibration fundamentals and a lot of time on data acquisition. Then we talk about vibration analysis and fault diagnosis and correction. As I say, we're not trying to make you at the Category 1 level into some sort of vibration expert, but we will take you through sort of how you go about doing spectrum analysis, and we'll take you through a number of the different fault conditions. What is happening inside the machine when there's unbalance, misalignment, when the gears are meshing together with some wear or misalignment or something like that, bearing, how the bearings work, how pump vanes work, and fans and so on. So part of the idea here is to fulfill the need to provide equipment knowledge training, which we do online and through the manual in quite a bit of detail, and we talk about all through the course. You need to know what's happening inside the machine, and you need to have a good feel for when the mesh changes or the flow doesn't flow correctly because of bent blades or blockages, and when there's turbulence, all these sorts of things. You just need to have a feel for what's going on inside the machine. In Category 2 we go much further with that and really explain why the vibration changes the way it does. But here we want you to understand the machines and understand that there's a real connection between how the machine is vibrating and how the machine is operating and how the vibration changes. So what are you about to see now? If you've got some time, because I will talk about this in a bit of detail, we can go through now each of the topics in just a little bit more detail than I just did then, but then I'm going to show you some of the animations and simulations that we use. What I've done is just taken samples of some of the slides, just from the course, so you still see some of the text that appears on the slide as well. So we brought that across into this presentation, so you just get a feel for what it's going to be like in the classroom. As I say, I'll briefly use some of the simulators so you get an idea of what you'll see, and you'll understand what we're going to teach you. So the first topic I mentioned was maintenance practices. And we give a quick introduction to breakdown maintenance, preventive maintenance or calendar-based maintenance, predictive maintenance or condition-based maintenance, and precision maintenance, also known as reliability-centered maintenance, and so on. The idea of this session is just to give you an idea of what they mean and to start thinking about the fact that there's a chance that the way maintenance is being approached in the plant is not ideal. We'll just open your eyes to the benefits, for example, of proactive or precision maintenance, taking care of the machines, not opening them up when it's not necessary, using condition monitoring technologies to plan your maintenance rather than using the calendar to plan your maintenance. So in it, we've just here's a simple little animation. It says, oh, the machines, they cause problems, but the machines are actually telling you what's wrong with them if you just understand the language. We talk about the fact that, most people think about machines failing this way. They've just been overhauled or they're brand new. Surely there's no risk of them failing. And after some time, in a predictable way, they will wear out. And what we explain is that for the majority of the machines in your plant, it's not true. In actual fact, there's a fair chance that right at the beginning, there's a high probability of the machine failing because of problems with workmanship, either off-site or at your site. It's just a fact of life, unfortunately. And the other problem is you don't really know when the machine's going to fail. It could fail soon, it could fail later, you just never know. So that's just something we talk about. And we talk about how you can use balancing and alignment to set up your machine for life. Balance it, align it, perform other functions, and the machine won't fail soon. So that's a good thing. And we try to just paint the bigger picture, how, if we design the machine properly in the first place, and we take care of the machine and we monitor it, and we remove those original causes of the problems, then the plant will be much more profitable. So then we talk a bit about condition monitoring. What is condition monitoring? And a quick introduction to each of the technologies. Now I've just got a couple of slides just to show you, some samples from it. But, in a course like the Category 1, we're not trying to make you an expert on each of these things, each of these technologies. The idea is that you understand what the technology brings, what its strengths and weaknesses are, just in basic terms. Category 2, we go into each one in more detail, but this one is a great way to get started to understand some of those technologies. So you see we've got movies showing how to use ultrasound, thermal images. We explain how emissivity works. A lot of people think that thermal cameras are great and measure temperature. They don't. They measure the infrared radiation. So we just give a quick introduction to the fact that, even though these copper bars might be the same temperature, the perfect black one will look hotter through your camera than the others. We just want to put these ideas in your mind that yes, there are strengths, yes, they all produce a complete picture of machine health, but you just need to be aware of some of the limitations. Then we get into the principles of vibration. This is the section where we're really going to bring home just, what machine vibration is all about. Explaining terms like frequency and units like CPM and hertz and millimeters per second, inches per second, all these terms, RMS, peak to peak, what all that stuff means. More importantly, we will create the picture in your mind that as the shaft rotates, as the gears mesh, as the veins move through the pump, you will understand why the vibration changes the way it does. So we cover, all the topics just at a level to help you understand what's going on. We have lots of simulators that help in this role, and I'll just quickly give you an idea of how they work. Each one of these little buttons, this is I Teach Vibration, just available to our instructors. It's not something that we sell. It's got lots of great simulator programs, but here is one that we use to explain just how the machine vibrates. So we say, okay, great, imagine if we were taking a vibration reading, from this shaft. What it's actually, even though we might not see any motion, there's actually that circular motion due to any unbalance or eccentricity or whatever it may be. And we want to measure the vibration. Well, one way to think about the vibration is if we used a dial indicator like this, and we've got a needle swinging back and forward as the shaft is moving from side to side. Well, what we can do is attach a chart recorder to that, and the pen on the chart recorder moves up and down synchronous with the needle moving back and forward. And if we start the paper, what do we see but a nice sine wave? We have another simulator actually that talks about things from the terms of just simple harmonic motion. Let's get that pen going. Let's show that graph. So there is the classic way of describing that sine wave motion, but I like to also show it in terms of the actual motion of the shaft, and we can then control the speed of the shaft, make it go slower or faster, and see how the vibration might change if that shaft was out of balance, for example. So that's one of the simulators we use in the program. We've got little flash programs that just make understanding these terms just a little bit more interesting. We do introduce the topic of phase so that you can see, okay, yes, one rotation of the shaft is 360 degrees, but we show it in a more visual way. Okay, this is connected to the data collector, this is connected to the data collector, and we can measure phase. We can do it with one accelerometer or with two accelerometers connected to your two-channel data collector. Now, the animations are great, but again, this particular simulator is very popular. It just makes it a bit easier to understand what's going on. We can take the reflective tape and put it up on the shaft, take the optical tack reference, could be a laser instead, but this is just an optical tack reference. We line that up with the reflective tape, and then we can start the machine and see the once per revolution signal that we get from the tack reference. And then we put our vibration sensor up on the machine, and we can see what the phase relationship is between the vibration on the motor and that once per revolution sensor there. Category 1, we're not going into a lot of detail about phase. It's just to sort of introduce the concept of it, explain what it means, and in this case show how you take a measurement with either a single channel analyzer or a two-channel analyzer or data collector. Once we get through an explanation of that, we talk about the vibration readings and say, well, okay, we can look at it in units of displacement, velocity and acceleration. And we've got a number of ways of explaining what the difference is, but this happens to be one of them. Here we've placed some cones on our little test track, and the car drives around them, and you notice it just conveniently maps out a little sine wave there. And with these tools here, I can make it go faster around those cones. I can put the cones further out. I can show what it looks like, if showing the velocity and the acceleration. So, look, with all these things, we have more time in the class to actually take you through each step by step. But you can see that this is perhaps a more interesting way of learning about it than perhaps otherwise. This little program makes a lot of noise and explains how overall level measurements work and how the ISO standards work. I've already mentioned that one. This one is a great one. This one's certainly one of the favourites. And one thing about teaching these courses, it's great fun teaching with these simulators because you see the students, you see the attendees, you understand things like never before. This simulator is here to explain what a spectrum is. And what I can do is turn on a bit of grey vibration, you can see it here, that's from the shaft. That's what we were looking at just before. But I also have some vibration from the bearing, and I have some vibration from the fan. Now over here I show the bearing vibration as the green wave and the fan vibration as the orange wave. We've got a green bearing and an orange fan. And if I had more bearing vibration, that one would be bigger. If the bearings were good, then there'd be actually no green vibration, but we'll just give it a little bit. If the machine was going faster, the waves all bunched together. If it's going slower, they're further apart. But the fact is that this is great, but when we measure the vibration from the sensor, we actually get this. This is just all the vibration that we would feel if we put our finger up on top of that bearing. But there is a way to break the vibration up into the vibration from the fan, the vibration from the bearing, and the vibration from the shaft. And that's with our magic FFT cube. This was time and amplitude. Now in this axis I've got frequency. Frequency, if it's going slower, if it's going faster, you can see the move along in frequency. And if I continue the rotation, I get a spectrum. There's the peak in the spectrum at the running speed of the machine. That was that grey vibration. There's the green vibration and there's the orange vibration. If the bearings get worse, then that vibration goes higher. And you can almost see that waveform behind there. Spectra, you don't show what's underneath. It's summed together and you're looking at the power spectrum anyway. You just see the top parts is the easiest way to look at it. So this is just one of the simulators that we've got in the class to explain what's going on. In the course we also talk about the forcing frequencies, how the fan generates vibration, how the belt does and all that sort of thing. We can actually play with the knobs and just make some more complex vibration. And then we actually go through some examples of saying, let's take some simple machines, let's show, let's calculate what the frequencies are. We don't do many calculations in this course, but one of the things you do need to do is say, well, if the machine had 6 pump vanes, then the vibration would be at 6 times the speed of the machine, that sort of thing. We also introduced the idea of orbit plots, that if we had vibration taken from 2 points which are 90 degrees apart, and we looked at that and plotted them against each other, we get an orbit. And we have a great simulator that explains how orbits work. And I can show, let's exaggerate that movement just a little bit. We'll make more space and make it vibrate. My 2 vibration sensors are measuring the displacement here, measuring the displacement there, and then what I'll do is show you the actual vibration that we are actually measuring and show that as an orbit plot. Again, in the classroom we have more time to go through this. In category 1, we're just trying to put the idea in your mind that if you work in a power station or in the petrochemical industry, there will be people using orbit diagrams to diagnose faults with journal bearing, the steam turbines and turbo compressors and whatnot. In category 2 we use this more, in category 3 we use it a lot. This has so many capabilities, but anyway. So, signal processing. For category 1 it's pretty basic. It's just saying what is going on inside the analyzer. Real basic terms. What are all the settings? Again, just in really basic terms. We just want you to understand when you see the messages on the screen, just to have an idea of what they mean. You need to understand that there are some settings you don't want to change unless you understand what they mean. And we want to put some ideas in your mind so that you might start to think, gee, I wonder if our data collector is being set up properly, because in a lot of cases it's not. We do that with a couple of programs actually, just to sort of help with the understanding. One is this great program that basically turns the computer into a vibration analyzer. You notice that as I'm talking, now the microphone from my computer is picking up the sound, and you're seeing it there. Hello, hello, hello. You can see it there as I make sounds. Well, I can show that as a spectrum as well. So if I whistle, I expect to see one nice clean peak. Well, would you believe that in the class we can do that? We can actually connect an accelerometer to the computer and hold it against your throat and make those same things. It turns the accelerometer into like a microphone, and you can see how the sensor works, how the data collector works, just in basic terms. It's just category 1, just basic terms. We've got another great simulator that again in category 1 we just use in a basic way, just to say, you know, the machine makes a sound, and you can see it doesn't, you know, it's not necessarily constant from one moment to the next. You can hear the sound, and you can see the spectrum down below. So yes, the analyzer doesn't just take one little tiny chunk of vibration and show you the results. It actually takes a number of chunks and averages it together to reduce the noise. Enough said for category 1, you know, but what we explain is that there are some very important settings. They must be chosen properly or you will miss out. You know, if the F-max isn't right, you miss out on this vibration. If the resolution isn't right, you miss out on this detail. If the units are not right, you miss out on vibration. You may overlook it. Filters are a term you hear from time to time with in this field, so we've got a great little simulator that explains that. And we talk just briefly about averaging. You find yourself looking at the analyzer, seeing the message averaging. Well, we just explain just briefly what the analyzer is actually doing. Just briefly explain that process, just what's happening inside. As I say, just so that you understand why it's doing it. So when you're taking your measurements, you'll see averaging 1, 2, 3, 4, 5, and you just want to know what it's doing so you don't get in there and change that number down to something smaller. Then we get into data acquisition. Now this is very important. You must take good measurements or else the person analysing the data will make mistakes. If the measurement isn't taken properly, it's very difficult to get an early warning of bearing faults. If it's not taken properly, the analyst will see changes in the vibration measurements and won't know if it's because the machine was operating under a different set of conditions, if you didn't put the sensor on the machine properly, or if there's actually something wrong with the machine. So we just take you through just to give you a good understanding of how to do it properly. We give you a brief introduction to how the different sensors work. You know, that was a proximity probe, a velocity probe, and a accelerometer. Just in case you're wondering, no, we do not sell accelerometers. We do not make accelerometers. We just make 3D animations of accelerometers and other things. So we just want you to explain, you know, how the sensors work, how the vibration gets from one part of the machine to another part of the machine. You know, to be very careful about where you place the sensor. You know, there are some places which are good places, others are definitely not. We explain briefly that there are different ways to mount the sensor, and while you may be using a method like this, I hope not, there are limitations with these sorts of methods. That's a great method. This is good, but has some limitations you need to be careful about. Quick connect probes are great, and always just need to be aware, you know, it might look like it's nicely painted, but you've got to be wondering what's underneath the paint, and that can really affect your measurements. You need to know how to put the sensor on properly too. And let's have a quick look at vibration analysis. In this section, the idea is to give you a quick introduction to the spectrum so that you can look at a spectrum and say, okay, I know why those peaks are there. I know that some peaks are there because of something called harmonics, some are there because there's noise, some are there because there's something called modulation. We don't explain it in any great detail. We just want to make you aware that these sorts of things are correct, and then to take you through a number of fault conditions so that you have an idea of how the spectrum is going to change, unbalanced misalignment, which I'll get to in a minute. We go through a nice example where we say, okay, let's start with a machine like this. How do we go about analysing it? Then we get into diagnosis, just explaining how the machines work for your equipment knowledge and how the forces inside the machine change when it's out of balance or it's misaligned or the gears are not right or the bearings and so on. And we do most of that with great animations and great plots to show you how the spectrum's going to change. So we've got lots of animations that just help you visualize what the machine's going through and how the spectrum changes. We've got lots of case studies that show you, well, here's a case where there was some build-up on an impeller and the vibration amplitudes got higher and higher. We explain just briefly how balancing works, for example. So with balancing, in the more advanced levels we talk about polar plots and how you do all of that, but for this we can say, well, let's take a rotor. We'll start with a simple single plane balancing. We'll start the rotor, and once it's stabilized we'll take a vibration reading, see what the original vibration is like. Then we'll put a trial weight on it. Okay, maybe not as big as that trial weight, but we'll put weight on it and see how the machine vibrates now. Well, we better start the machine, I guess. We'll start the machine, let it run up, wait until it's stable, take another vibration reading. And by putting that trial weight on, we now know how we've influenced the machine, and we can then calculate where the weight should be placed and how much weight should be positioned on those blades to balance the machine. So the system might tell us, yeah, we need to put a little bit of weight on this blade, a little bit of weight on that blade, and that will solve the problem, solve the balance. And yes, we can show you all the vectors, but for category 1 we're just trying to open your eyes to how that process works. We also explain misalignment, how the vibration changes when a machine's out of alignment, and we explain how we can use dial indicators and laser alignment systems to align the machine. Don't look into the laser beam, by the way. We then talk about looseness. What if the bearing's moving around inside the housing? What if there's too much clearance in the bearing and the shaft's moving around? Some of the animations are a bit exaggerated, but it's just to sort of get the message across that the shaft might be moving around, rattling around, and that changes the vibration in a certain way. We talk about the vibration with pillow block bearings. We look inside the bearing and say, what if there's damage on the on the rolling elements, or on the inner race of the bearing, or on the outer race of the bearing? It's going to change the vibration, but it changes it in predictable ways. You really should, after these slides, after this session of the course, really have a great understanding about how the equipment works and how the forces change, and thus how the vibration changes as these faults develop. We've got a great simulator that maps it all out with demonstrating exactly how bearings vibrate. And then we tell you a little bit about the electric motors and what happens if there's a soft foot problem, what happens if there's broken rotor bars or something like that. Just give you an idea about the different sorts of machines. A little bit about belt drives, a little bit about gearboxes as well. What's happening inside the gearbox, and why the vibration will change if they're eccentric or misaligned, or there's a broken tooth, and this sort of thing. And finally, we talk about the alarm limits. You need to understand the 10816 standard, the ISO standard, and the 7919 standard, and just give you an introduction to band alarms, mask alarms, and so on. This is one of the standards that we've sort of made just a little bit more interesting. Choose your machine, how's it what sort of machine is it, what's the vibration like, and therefore is it in good condition or not. That's a very basic way to set the alarm limits. We talk about some other ways as well. As the Category 1 vibration analyst, you're expected to understand these things. You're expected to be able to take very good measurements. Ideally at your site there should be a Category 2, there should really be a Category 3 vibration analyst making the decisions and making the final diagnoses. In some plants we recognise that you might buy a vibration analyzer and start doing vibration, and this will be your first training. So we want to help prepare you to do a much better job, but we're also trying to warn you of all the sorts of mistakes you might be making, so that if you don't have a more advanced person, you might either want to employ one or use a consultant. Otherwise, if you're in a bigger group, then this will just provide great training for you. Well, thank you for going through this presentation. I hope you have a really good feeling for how the Category 1 course works, the sorts of topics we cover, whether it's right for you, and what makes our course different. All the animations and simulations and the preparation we give you before the course and so on. Thank you very much for attending the course, for attending this presentation. And if you have any questions, there's lots of information on the website, but feel free to email learn@mobiusinstitute.com. We look forward to hearing from you. Thanks very much.